As we said, music is the rational organization of sounds and silences passing through time. That's my definition. You can have your own. And it's a general one, maybe a bit wordy. A more down-to-earth definition would say that music, indeed any sound, is simply a disturbance of the atmosphere. But music is a regularly organized disturbance of the atmosphere, resulting in sound waves coming in regular patterns. Sound waves are simply differing air pressures, air being compressed or air being expanded. And the pattern is regularly repeated. We have large sound waves and smaller sound waves. Large ones generate low pitches. Small ones generate high pitches. A very long string creates an equally long sound and a low sound. Now this string on the piano here is vibrating about 30 times per second. The highest note on the piano, way up here, the highest note on the piano is vibrating about 4,000 times per second. We don't hear all those 4,000 vibrations, but they can be measured in a laboratory. Let's take a look at a diagram here. It shows a pitch on top and multiples of it underneath. Indeed, you see 4 pitches here on this particular screen from top to bottom. The top one is shaking, vibrating about 110 times per second. If we double the vibration to 220 times per second, we get this sound. If we double it again to 440 per second, we get this sound. And indeed, this is the pitch that the oboe plays at the beginning of orchestral concerts to give the pitch for the rest of the instruments to tune to. Then, as you see on the bottom, if we double this yet again, we get 880 vibrations per second. That low sound wave down here, that's actually physically a little less than 12 feet long as it goes unseen but heard through the atmosphere. 220, well, that's a little less than 6 feet. A440, somewhat less than 3 feet. Obviously, to be heard, sound must reach the ear. Once there, sound waves enter the inner ear and ultimately are changed into electrochemical impulses. The heavy lifting here occurs in a small organ called the basilar membrane. Here, filaments called cilia are activated by particular sound waves. In other words, the basilar membrane is tonotopic. Each of the many cilia responds to only one frequency, high or low. When stimulated by a particular sound wave, the cilia send a signal. Hey brain, heads up. The frequency A440 is coming in. The sound goes to the brain. Through, first, the primary auditory nerve, and then to the left and right side of the cortex. So here on the screen, you see the left side of the brain, the left cortex. In the gray area, we have the temporal lobe, and within the temporal lobe, the primary auditory cortex, where much of the processing of sound occurs. It too is tonotopic. The neurons there respond only to particular frequencies. All of this is something of a simplification, but it gives you a general sense of what is happening as musical sounds enter our ear and our brain. And it's complex because many parts of the brain are engaged when we listen to music. The frontal lobe, as you see out there to the left in the green color, and the prefrontal lobe. They might be involved in issues that, where am I in this piece? You got to use thinking. That's what that's for. The parietal lobe, well, that involves movement. If I'm playing I have to coordinate my auditory processes with physical processes here involving the motor cortex. In addition, well, we might have to remember. We might have to think about, well, have I heard this before? And that might involve the hippocampus. And there is a vast and certainly not fully understood interconnected network of associative linkage in the brain, with the information being sent around at about 250 miles per hour. So a lot is happening when we listen to music, and it's happening very fast. And that says nothing about how we feel about the music, which to some measure is the responsibility of another part of the brain, the limbic system, including the amygdala. Whew, it is complicated. Maybe the brain is as mysterious as music itself. And while we're on the subject of music and the brain, let's think about how it is that music excites us or relaxes us, gets us pumped up to lift weights or run, or calms us down at night. In our brain, information about sound is transformed, as we have said, into electrochemical impulses, into chemical neurotransmitters such as dopamine and glutamates. These move from one cell to the next, exciting or inhibiting the neighboring cells, causing us in one way or another to get excited or to relax. But likely you know all this from your biology and chemistry courses. Neuroscientists have discovered that music has the same effect as, quote, and I'm not kidding, quote, other euphoria-inducing stimuli, such as food, sex, and drugs of abuse, end quote. So that's interesting. Music is like candy for the mind. So don't take drugs, listen to music. It's a lot better for you.